everybody. Hope you're having a fabulous Tuesday, and I hope that the Khan Academy videos that you watched will help you refresh your memory on solving these inequalities. Sorry, my brain stopped moving for a second there. All right, so this is lesson 6, and it is the last lesson for this unit. So your homework tonight will be page 38. Numbers 1 through 5 and 7. Oh, what happened? This is not connected. Ah, there we go. Sorry about that. iPad disconnected. So this is lesson 6. Is the last lesson, and your homework tonight is on page 38, and it's numbers 1 through 5 and 7. So once you do those, I will post the answers later this week. Check Teams for all those details, and we won't have another video this week. What I'll do is either Thursday or Friday, I will post a review sheet. Actually, the review sheet is already in your Teams Files Unit 9 folder. So if you go in there, if you can't print it, it's totally fine. You just do it on a separate sheet of paper. But that'll be due by next week sometime. So again, check Teams after this stream for full details on all of that. So let us dive in. Nope, flip back to the right page. All right. So you will be able to solve inequalities involving polynomials and rational functions using both algebraic and graphical techniques. Let's explore some common connections between inequalities and the positive and negative sign of the expression. So if f of x is greater than 0, to solve f of x is greater than 0, is to find the values of x that make f of x positive. And to solve f of x is less than 0 is to find the values of x that make f of x negative. So remember, f of x, fancy way to say y. All right. So a lot of this will be what techniques you've already done, but now we're just giving a little bit more detail to it. So we have the following polynomial: f of x equals x plus 3 times x minus 4, the quantity squared. Determine the real number values of x that cause f of x to be 0, positive, and negative. So 0 is not too bad. That's just our roots. So that's going to be x equals negative 3 and x equals 4. Remember, that's going to have a multiplicity of 2. And off to the side, I am just going to kind of sketch a little diagram of it, because for me, having a visual is very helpful. So here's negative 3. We'll say this is 4. Okay. So change colors there. We're going to use something called a sine table or sine line, whatever you want to call it. We did this earlier in another lesson. And we're going to test the sign for y. So on here, we're going to put our negative 3 and 4, and we want to figure out what is this picture going to look like. And that means if it's negative, it's going to be below the x-axis, and if it's positive, it's going to be above the y-axis. So what we really do is we just pick values to plug into our original function to see, is it positive or negative. So I got to find a number that's smaller than negative 3. So if we put in negative 5, for instance, I'd have negative 2 times some positive number, which means it will be negative, which will be below the x-axis. Okay. So negative, that's going to be negative infinity to negative 3 so far. And then we got to pick a value in between 3 and 4 to plug in, so it really doesn't matter. We could plug in 1. 1's a great number. So we'd have 4 times some positive number because it's being squared, so that's going to be positive. So that's going to be above the x-axis. So positive, we have between negative 3 and 4. And then we have to pick a number that's bigger than 4. Well, that's going to make everything positive, so we're still positive there. And I'm just picking numbers, plugging them into that original f of x, and seeing what my sign is. So this would also be 4 to infinity. Now, if you recall, the reason I stated the multiplicity is because that's going to tell me if I'm going to be crossing or just touching. This is going to kind of verify that. So with a multiplicity that is odd, we cross the x-axis. So we're below, and then we're going to be above. And then with a multiplicity of 2, I touch, but I do not cross. So knowing those rules from earlier in the unit, combined with this sign test, we can see that that is truly true. So, not too bad. Nothing we haven't really done so far. Just kind of putting a few topics together. Okay, let's scroll to the next one. Finding where a polynomial is 0, positive, or negative. So with this one, there might be some undefinedness. We have to look at the denominator. Okay. So if I have 2x minus 1, we know it's not allowed to be equal to 0. So if you solved for x, we would get 1/2. So we're going to have, this function will be undefined line, an asymptote at positive half. All right. We're going to use our numerator to find our zeros. So just like what we were doing last week. So therefore, we have -3 and +5, both with a multiplicity of 1. And we got to figure out where is this going to be positive and negative. So on my line, I'm going to put some important information. We're going to have -3. We're going to have that half, which we know is just going to be an asymptote. And we're going to have +5. And we're going to do the same thing we did above. I'm just going to pick values that are not stated on the line. I'm not going to pick -3 because we already know it's going to be 0, so that's super boring. And see, are we going to get a positive answer or a negative answer? So if I have to pick something below -3, so maybe -5, we would plug that into r of x, and we would get a negative number. I don't care what the negative number is. I just care that it's negative. So again, that's going to mean we are below. Then I got to pick a number between -3 and +1/2. So I needed that half there because that's going to give us, a little smaller interval of if we're going to have a positive or negative function there. But we know we're not going to cross it because it's an asymptote. So if I pick like -1, doesn't matter, we're going to get a positive value. And then I'm going to pick something like between 1/2 and 5. So maybe I pick +1 because it's just an easy number to work with. We would get a negative number. And if I pick something greater than 5, maybe I pick 10. That's going to give us a positive value as well. So if we go to graph this, we have -3. Maybe we have our half here. So that's my asymptote. And I have +5. Okay, obviously not drawn to scale, and that's okay. All right, so we start from below, and we go to above. And then, let's see, we were below between 1/2 and 5, and then we went positive. Oops. So maybe it's something like that. So for me, you can use the table to determine your positive and negative intervals, but sometimes it's easier to look at a picture. So for positive, that's going to be between -3 and 1/2. And it's also going to be 5 to infinity. Now I'm doing parentheses because if I did brackets, that means I would be positive at -3, which is not true. We're at a 0 there. Okay. And then negative, we are -infinity to -3. And then also between 1/2 and 5. So nothing too earth-shattering there. Okay, so that's all some review. All right, solving a polynomial in inequality analytically. Wow, that was quite the mouthful. All right, P over Q. We remember this deal. But first, we have this less than or equal to 0. So what that means is we must be below or on, because it's or equal to, the x-axis. So if we were going to think of it visually, that's what it means. So anything above the x-axis, not an answer to this polynomial. So there's a few different ways that we can find roots from here. We can do factor by grouping. This is kind of leaning us towards a P over Q method. So if we recall, the p-values come from the constant. So all the factors of 6 would be like plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. And then for Q, it's the coefficient of the leading term, which in this case is just plus or minus 1. So that makes it kind of easy for us. So if I'm doing P over Q, I'm just dividing all of those by 1. Nothing too earth-shattering there. All my options for roots would be plus or minus 1. Technically 1 over 1, which is just 1. So it's just really going to be all of those p-values. Now recall that last time we would do like f of 1, f of negative 1, f of 2, f of negative 2, f of 3, f of negative 3, and so on and so forth to find our roots. And remember, that was just like super exhausting, and you're like, God, is this ever going to end, right? There's a little bit more of a systematic approach we could do to it. We could actually do some synthetic division and find some roots there. So I'm just going to pick a number and hope that when I synthetically divide, I don't have a remainder. Because if I don't have a remainder, that means that it's truly a factor of it. So let's try 2. 1's boring, so I'm going to go with 2. I'm going to try positive 2, because why not? So recall synthetic division. We're going to write our coefficients down. So we have 1, negative 4, 1, and 6. And that first term comes down. I put my little box for my remainder. And then we do 2 times 1, which is 2. Negative 4 combined with 2, excuse me, is negative 2. And then 2 times negative 2 is negative 4. 1 and negative 4 give us negative 3. 2 times negative 3 is negative 6. And bam, no remainder. So we're really left with x squared minus 2x minus 3 equals 0. And that's nice because we could actually factor that to find the rest of the roots. So that's going to be x minus 3 times x plus 1 is 0. So therefore, those roots is x equals 3 and x equals negative 1. And also, x equals 2 was a part of that. So since this really means x equals 2, if I wanted to write those as my factored bubbles, I would really have x minus 2, x minus 3, and x plus 1 is less than or equal to 0. So kind of neat. Nice little quick way. Again, you could check all of those, plugging in 1, negative 1, 2, negative 2, etc. But this way is just a little bit nicer of a systematic approach. And I just got lucky. I picked 2 and it worked out. Yay for me. I could have picked 3 and it would have worked. I could have picked 1 and I would have done the same process, just factored and solved. So it's really not too sketchy. So now that I have all of my roots, let's do the sign test. So that means we're going to have negative 1, 2, and 3. And again, we're just picking numbers in those intervals into our original function. So if I pick something smaller than negative 1, like negative 5, if I plug that in, I'm actually going to get a negative number. So that's going to be below. If I pick something between negative 1 and 2, like 0, I would end up with 6, so that's positive. If I pick something between 2 and 3, so 2.5, I plug it in, I end up getting a negative number. If I pick something greater than 3, like 10, I'm definitely going to be getting a very large positive number. So remember, with our solutions, we couldn't be positive. That was not in the cards for us. So that's going to be from negative infinity to negative 1, and between, oh, actually, I could, hold on. Because it did say or equal to, right? So since I'm allowed to have zeros, I'm going to, if my pen decides to work, there we go. Little late to the game, pen. I can box it in because I'm allowed to have those roots included. Because it said less than or equal to 0. Very good. And you can always sketch a picture of that, but since we're looking for negative things, you know, you can look at the sign chart. I'm not going to do this one. All right. So let's flip the page to page 37. I'm not doing this top part. But we're going to do examples 6 and 7 and then call it a day. Other inequalities. So our first one has a nice bubble, but then it has a radical, so kind of a bummer. So what I'm going to do is split those up and find my roots individually. So I have x minus 2 is less than or equal to 0. So x is going to be less than or equal to 2. And then I have radical x plus 1 is less than or equal to 0. How do I get rid of that radical? I can square each side. That's just going to leave me with x plus 1 is less than or equal to 0. So we really get x is less than or equal to negative 1. There we go. And then from there, we can do our sign table because we're just really trying to find out what values work for this. And again, it is less than or equal to, so we got to keep that in mind. So we have negative 1. And we have 2. And we're just plugging these back into that function to see is my answer positive or negative. So if I pick something smaller than negative 1, I actually get undefined. We got that radical there. I'm not dealing with imaginary numbers. Between negative 1 and 2, I could pick like 0 if I wanted to. That's going to give me a negative number. And then if I pick something greater than 2, like 5, that's going to give me a positive number. So it said less than or equal to 0. And that is going to be between negative 1 and 2. And I'm allowed to include it because it was or equal to. So allowed to be included, not just the negative part, but also the 0 part is valid as well. It's not too shabby. Let's try one more and we'll call it a day. All right. So right away I see a fraction in its absolute value, which is cool because it makes it positive, but it will still be undefined at positive 4. And if I want to look at my root, I look at my negative, or excuse me, I look at my numerator. So the numerator gives me my zeros, which x plus 1 is less, oh, not less than, oh, we switched it up today, is greater than or equal to 0, so a little different than the last one. So x is going to be greater than or equal to negative 1. And we're trying to figure out where this is going to be greater than. Well, if you're not a big fan of the table, we can always graph a picture. I like pictures. My college professor, Dr. Kwong, loved pictures. We know about him. So undefined at positive 4, maybe that's here. My asymptote. I've got negative 1 over here. And it's a multiplicity of 1. And since my x is positive, I know this is going... actually, let's do our sign table. So we have negative 1 and 4. If you pick something smaller than negative 1, I'm going to get a negative number. Between negative 1 and 4, I would get a positive number. I got my asymptote. So let's see. Let me change colors. We're going to look something like this. It's not going to be quite exact. And then after, we're going to be above as well. And again, I'm just plugging numbers in. Going a little faster though, so I'm not as to bore you in this video. And you can always pause when you're on YouTube. So we're doing greater than or equal to. So between, oh, or equal to. Ah, I'm like brainwashed over here. And actually, I drew this kind of poor. It's going to be above, but it might look something like that. So we have between -1 and 4. I'm not going to include 4, though, because that's my asymptote. So that is going to get a parenthesis. And 4 to infinity. So, again, your homework is on the next page. We're not going to do this box question. Is 1 through 5 and 7. So, I have my morning office hours every day from 10 to 11. And then, of course, tomorrow is Wednesday, so you have your pre-calc exclusive office hours in the afternoon from 1 to 2. So, hope you have a fabulous day, and hope to see you in my office hours. And